You are going to want a calculator for these notes, so make sure you have your calculator out. Today we're going to look at correlations and best fitting lines. Scatter plots are graphs that are used to determine whether there's a relationship between paired data. Positive correlation is when y tends to increase as x increases. So if we have a scatter plot where the data seems to be scattered around a line with positive slope, then that would have positive correlation. Negative correlation would be a scatter plot where the data appears to be scattered along a line of negative slope. The y values decrease as the x values increase. If there's no linear pattern whatsoever, that means there's no correlation, relatively no correlation. Here's the steps that we're going to follow to approximate a best fitting line. We are going to carefully draw a scatter plot of the data, make sure you use graph paper, and think about the scale of your graph. Try to make sure that your scale fits so that you're not graphing a whole bunch of stuff just in a tiny little space. You want it to be spread out so you can really see what you're looking at. Once you have the scatter plots plotted, sketch the line that appears to follow most closely the pattern given by those points. And we'll talk about that once we get there. And honestly, we'll talk about the rest of these steps once we get there. So the first thing we need to do is, here's our graph. We need to draw a scatter plot of this data. Excuse me. Now, look at the data. Our x values go from -2 to 5. Our y values, looks like the smallest one is -2.5 and the largest one is 4. So I'm thinking, I see a lot of 0.5s in here. It'd be really nice if each line on my graph represented 0.5. So if I did that, I would put my y-axis right down the middle and my x-axis in the middle. So this would be 0.5 and this would be 1, 1.5, 2, 2.5, 3, 3.5, 4, and 5. And you don't have to label every single tick mark. That's -5. You could even do like just -2 and -4. And then the y values also have 0.5s, so I'm going to do that same thing. So there's 2, 4, now let's plot the points that we have. So plot the points carefully. If you need to, pause the video and then get the points plotted so that you're not getting behind. So the first point is -2, 4. That means -2, so -2, that's 2 to the left, up 4. That would be that point right there. Remember, your x values, you move side to side. Your y values, you move up and down. The point -1, 3. 1 to the left, up 3. Okay, take a minute, pause the video, plot your points, and then play the video and check your points. By the way, the point 0, 2.5, that's 0 side to side, up 2.5. Okay, now seriously, pause the video, plot the rest of the points. I mean it. Pause the video. Now that I have all the points on here, take a minute, check to make sure that your points are all in the right place. So pause the video, look at the screen, make sure that the points are all in the right place. Now we need to talk about best fitting lines. So you don't necessarily want to draw the line through data points. So you don't want to pick 2 of these points and then draw the line through those 2 points. Basically, if the line happens to hit a data value, fine, but don't try to make it hit one of your points. And I know you can't really see what I'm doing, but if you heard that, I have a clear ruler that I put over my graph, and I'm moving that ruler around until I can figure out what would be a good line. So I'm going to draw one in that is not a best fitting line so we can talk about it. This is not a best fitting line because all of the points are below it. This is also not a best fitting line because all of the points are above it. You want a line that seems to match the general slope of your points, but you want to try to equalize the space between each point and the line. So again, don't try to hit a data point, but also don't avoid a data point. I don't know if that makes any sense, but don't try to hit a point, but don't try to avoid the points either. So I just drew this in, and if I count, I've got 1, 2, 3, 4, 5 points below the line, and 1, 2, 3, 4, about 5 points above the line. And it seems to kind of fit with the slope of the points, so I'm going to call this my best fitting line. Now from here on, your notes might look different from mine because there's no way you're going to draw the exact same line that I just drew. Okay, my next goal is to find 2 points on the blue line that I drew. And you don't just want to say, oh, that point right there, because that point is not something that you can easily find. Oh no, I didn't want to do that. Hold on. So as you're looking along this line, look for places where the line that you drew perfectly goes over the grid. Like this would probably be a good point for me to pick. You don't want to pick 2 points that are too close to each other. So if you pick one point kind of on the upper side of the line, you want to look on the lower side of the line for another point. And if you can't find one that's perfectly like this point is good because it's 3.5 for the x value. And then the y value is negative 1.75. So you can do that if necessary, because really, as I look through here, that one is right on the grid. That point is easy to pick out. That's the 0.11. But I really don't have any other points that are perfectly on that grid that would be easy to use. So the points I am using are 1, 1, and 3.5, negative 1.75. You probably have 2 different points based on the line you drew. I would check with the people around you once you have your line drawn and see if other people agree that you've picked good points. But from this point on, this is what we've been doing in class the last few days. You've got 2 points, so your next step is find your slope. So again, your points are different from mine. Your slope might end up different from mine. And don't worry if there's crazy decimals. That's going to happen. So my slope is negative 1.1. And if you need to pause to catch up, that's fine. So pause, get to a point where you have your slope. Once you have your slope, you need to pick one of your points. Again, it's not going to match mine. We are going to have different answers. But then you're going to use point slope form. Y minus y1 equals m times x minus x1. And you're going to put your slope in place of m, one of your points, the x value, in place of x1, and your y value in place of y1. So mine, I will do y minus 1 equals negative 1.1 times x minus 1. Your next step is to get this into slope-intercept form. So distribute your slope. and get y by itself. And that is the equation of the line that you drew that you think best fits the data. And if you check, you should have negative slope because our line looks like it has negative slope. And it looks like mine crosses the y-axis at about 2.1, so that y-intercept does make sense. Now, this is the approximation of the line of best fit. The true line of best fit, we would have to use a calculator program to really find the best fit, but this is the process that you would follow. So let's go back up here and look at the steps. So carefully draw the scatter plot. Make sure you think about scale, use your graph paper, and be accurate. Sketch the line that most closely follows the pattern given by the points. There should be about as many points above the line as below it, and the space between the points and your line should be equalized. So try to even out, this point here is farther away from the line, but the others are kind of close. Some of these are close and only 2 of them are kind of far away. So just try to equalize that space. Choose 2 points on the line that you drew. Estimate the coordinates of each point. These 2 points do not have to be original data points. In fact, it's often better if they are not. Notice when I drew my line, I didn't try to hit the data points, but you also don't want to completely avoid the data points either. So try but don't try, if that makes any sense. Then find the equation of the line that you drew. So you found 2 points. Find the slope of those 2 points, and then plug that into point slope form, and then get your equation into slope intercept form. And your final answer is your equation in slope intercept form.